Yes, in this class we will discuss about non-linear programming. So linear programming we have done already using simplex method and graphical method. Non-linear programming means the function f of x contains non-linear terms. Non-linear terms. Non-linear means we can have x square, x cube like that. So x square, x cube terms if we have, then it is a non-linear function. So then such types of problems are also solved either by using constraints or without using constraints. So here I discuss only unconstrained. Unconstrained optimization means you don't have any constraints. No constraints are given. Just they will give a function y is equal to f of x and they will ask you to find the maximum or minimum value of that function. So it is also called a single variable function because only x is the variable. So y depends only on x. So if you plot a graph, I will take that to explain the minimum and maximum values. So minimum and maximum values of a function can be expressed in two ways. One is the global value. Another one is local value. Global value is also called as absolute value, whereas local value is also called as relative value. So if you take a function y is equal to f of x and if you plot a graph, I have taken a graph like this. So this is the graph of y is equal to f of x. It's a curve. So I have marked some points on this graph a, b, c, d, e, f, g. So x value I have taken from x is equal to a to x is equal to b. So that means the range is a to b, which is called as the domain, including a and b. So this is the domain of x value. So the lower limit of the domain is a, upper limit of the domain is b. In between you have values x is equal to x1, x2, x3, x4, x5 like that. So the meaning of this is at the point a, x is equal to a, at the point b, x is equal to x1, at the point c, x is equal to x2, at the point d, x is equal to x3, at the point e, x is equal to x4, at the point f, x is equal to x1, and at the point g, x is equal to b. Now if you plot the graph, you may get some value points and width points. So these are called width points, these are called value points. So if I mark the value and width points, for example here b is a width point and c is a value point. D, it is actually at point D, if you draw a tangent, so there is no, what you can say, at this point D, to the left of D or right of D, it is horizontal. There is no increase or decrease of that value. Then at E is a width point, F is a value point, D is a width point. Now here, if you observe the minimum value, so we have two minimum values here, at C and at F. So like this, you may have one more minimum value here. So somewhere if you plot like this, you may get one more minimum value here. So like that, you just plot all the minimum values. Here I have given only two minimum values, C and F. So among them, whichever is minimum, that is called as the global minimum. So global minimum is the minimum of all local minimum values of the function. So you may have one more value here. So this is local minimum, that is local minimum. This is also local minimum, but I have to take the minimum of all the local minimums. That is called as the global minimum. Similarly, the maximum of all the local maximum values is called as global maximum. Here you have B and E. B and E as the maximum values. Among these two, the higher value is at E. So that is why it is called as global maximum. So only one global maximum, one global minimum value will be there. Other minimum values, other maximum values are local minimum and local maximum values. So is how we can judge the local and global minimum values. And at some point, as I already told, so there may not be any increase or decrease of f of x value near that point, left or right of that point. That point is called as inflection point. Inflection point. Now, in other words, if I want to say a function f of x is said to achieve its maximum value at a point x is equal to x naught, we say that at x is equal to x naught it has got maximum value provided f of x naught plus h less than f of x naught. That means whatever value of f of x you are going to find at x is equal to x naught, it should be greater than any other value. It should be greater than any other value. That is why it is greater sign. Then we say that this value is maximum. Suppose, in other words, a function y is equal to f of x is said to achieve its minimum value if it is lesser. Okay? If it is lesser, then it is called as minimum value. And global minimum, global maximum, I told already. Now there are two important conditions to find out the local minimum and the local maximum value. So what we say is a function, you can, for a function y is equal to f of x, you can find out the minimum value and maximum value using two important conditions. The first condition is called necessary condition. Necessary condition is the derivative of that function should be equal to 0. That means y is equal to f of x will be given. Find the derivative of that function with respect to x, equate it to 0. So once you equate it to 0, you are going to get some value of x. That value of x we can call it as x naught. Some value of x you are going to get. Then the second condition is the second derivative d square by dx square or y double dash x if at that point, at which point at x is equal to x naught point, if it is less than 0, that means if it is negative, if that value is negative, then we say that that is the maximum point. So less than 0, maximum point. Negative on the maximum. Positive on the, this is at x is equal to x naught. If you put x is equal to x naught in the second derivative, then if you get negative, positive value greater than 0, then it is called as minimum value point. If it is equal to 0, then it is called as inflection point. Three conditions. So this is the sufficient condition. So first derivative, if it is 0, that is a necessary condition from which you can get the value of x. Some value of x. I will take a problem now. Next sufficient condition is at the same point if you find the second derivative, if it is negative, it is maximum value. If it is positive, it is minimum value. And if it is 0, it is inflection. Now let us take up a problem. How to find the maximum and minimum value of the function. Of course, it is for local, not for the global. Okay. So what condition we are using here? That is for the local minimum and maximum value. Now he has given one function like this. F of x is equal to f of x is equal to 10x square divided by 30 plus 150 into 60 minus x whole square divided by 20. Sorry, 60. This is 60. This is also 60. Of course, here you can simplify this further. X square by 6, correct? Plus here it is 5 by 2 into 60 minus x, correct? So this is your given function. You can observe that square term is there here. That means it is a non-linear function. Non-linear function. So y is equal to f of x. This is your y is equal to f of x. So this is, you can see that this whatever is there, the RHS is non-linear. Now let us find out the maximum and whether we can have the maximum value or minimum value or inflection point. Among these three, you will get one. Okay. So for that, what we have to do, first condition is we have to derive. We have to differentiate it with respect to x and equate it to 0. So first condition is dy by dx is equal to 0. So if you take dy by dx is equal to 0, so differentiate this with respect to x. Here I have to 2x by 6, correct? Plus 5 by 2 into, then I take 2 times 60 minus x into minus 1. Correct? Differentiate ಗೊತ್ತಿರಬೇಕು. So we have to solve this now. If you solve this, what happens to this equation? X by 3 plus 2 cancel, right? Plus minus 5 into 60 is 300 minus 5x plus 5x, correct? Sorry, na? See, 5 into 60 is 300 minus 300 agutte plus 5x, correct? Solve for x is equal to x by 3 plus 5x is how much? So x plus 15, x divided by 3 minus 300 is equal to 0. Or 16x by 3 is equal to 300. Or x is equal to how much? So 16x is equal to 900. So what is x? X is like that. 900 by 16 is
56.25.
56.25. 600. Okay. 56 point. Okay. This is the value of x equal. This is x not active. This is what? No. Okay. So that is first condition we have to apply. Next, second condition we have to apply. Second condition if you want to apply, you have to take second derivative. D square y by dx square, which is equal to y double dash x. So once again we have to differentiate this. This is differentiate ಮಾಡಬೇಕಲ್ವಾ? ಇತ್ತನೆ divided by dx ಅಲ್ವಾ? This is equal divided by dx after simplification. So that means you have got 16x. So it is nothing but d by dx of dy by dx. Second derivative. That is d by dx of dy by dx is this 16x by 3 minus 300. Alva? This is dy by dx. So here differentiate ಮಾಡಿದಾಗ positive or negative. What happens here? This is 16 by 3. 300 is 0 alva? Constant. So 16 by 3 is the derivative. 16 by 3 is positive. Greater than 0. Correct? Greater than 0 it is the minimum point. Minimum value point. So it is a minimum value point. Now what is the minimum value? If you want to find the minimum value, substitute x is equal to 56.25 in this given function. A function substitute for the minimum value. So therefore, minimum value of the function is equal to, so put x is equal to 56.25 in that given function. The minimum value of the function. So the maximum minimum also ಗೊತ್ತಾಗುತ್ತೆ ನಿಮಗೆ positive negative ಅಂತ. So minimum value of given function is y minimum is equal to, put x is equal to 56.25 given function. So that is, this is the given function, x square by 6, x is x square by 6 plus 5 by 2 into 60 minus 6 whole square. So x square is 56.25 square divided by 6 plus 5 by 2 into 60 minus 56.25 square. What is the answer? Just put that.
677.
6, 7.
677 ಬಂತು ಮತ್ತೆ ಇದು
56.25 whole square by 6.
677.499.
677.5.
499 5000.
677.5. Correct? Okay, this is the, and we will find out the value of x, value of f of x at x is equal to 0 also. X is equal to 0 now ಏನು ಬರುತ್ತೆ ನೋಡೋಣ. Just let us check this. So ಅದೇನಾಗುತ್ತೆ y minimum. Y is equal to ಹೀಗೆ ಬರುತ್ತೆ y is equal to ಏನು ಬರುತ್ತೆ 0 ಅಂತ ಏನಾಗುತ್ತೆ ಇದು x square by 6 plus 5 by 2 into 16 minus 6 whole square ಅಂದರೆ this first term 0 ಆಗುತ್ತೆ. ಸೆಕೆಂಡ್ ಟರ್ಮ್ ಬಂದು 5 by 2 into 60 square ಅಂದರೆ 3600. ಇದೆಷ್ಟು ಬರುತ್ತೆ
9000.
9000. Among these two the minimum is 10. Alva, among these two the minimum value is 677.5. So that is the answer. So this is the minimum value of the function. Sometimes you may get x is equal to 0. E point and minimum ಬರ್ಬೋದು. But ಇಲ್ಲಿ ಬಂದಿಲ್ಲ. It all depends on the given function. Okay? This is how we can find out the maximum or minimum of a non-linear function. Two conditions we are using. First condition is dy by dx is equal to 0. Second condition is d square by dx square. If the value of d square by dx square is positive, then we get the minimum value. If it is negative, we get the maximum